Hi, in this video, we're going to take a look at Switchport security. So switches are vulnerable to a variety of attacks, including password attacks, denial of service attacks, Cisco Discovery Protocol attacks, MAC address flooding attacks, and DHCP attacks. And there's various mitigation techniques to stop these. Disabling unused ports, disabling CDP, configuring port security, which we're going to take a look at, and configuring DHCP snooping. So we'll take a look at MAC address flooding issue in this video. I'll address some of these other attacks in later videos. Okay, so one of the easiest things you can do to protect your switch, and just good best practice, disable any unused ports and assign those ports to a garbage VLAN. So in this case, let's say we have ports 20 through 24 that are currently not being used on the switch. We assign them to this unused garbage VLAN 100, and we disable the ports, put them into shutdown mode. Okay. The reason why this is a good idea is that when we are ready to use that port, to assign it to whatever VLAN, we have to explicitly assign it to a VLAN, because by default, it's in this garbage VLAN. So that makes sure that we don't just leave it to whatever the default VLAN might be, like VLAN 1, which is the default VLAN by default. Okay, so it makes us do our job correctly in best practice and make sure we assign that port to the proper VLAN. Okay, Unicast flooding. So let's talk about this. By default, switches will learn how to build their MAC address table by examining the source MAC address. So in this case here, frame comes into port 1. It says, I don't know about that. About this MAC address on this port number, I assign that MAC address to that port. And then to forward frames, it examines the destination MAC address. In this case, the destination MAC address is not in the table, so it floods it out all ports. This is known as an unknown unicast. The Ethernet frame destination MAC address is a unicast, but it's unknown to the switch, so it floods it out all ports. Well, what if an attacker filled up our table with bogus MAC addresses? Okay, what would happen? Well, when a frame entered the switch port from a legitimate device, first of all, it wouldn't learn the source MAC address because the MAC address table is full, and then it would also flood that frame out all ports. And let's say an attacker did that to our entire local area network. Okay, well, the attacker would see all these unknown unicast frames because it would come to every device. All right, so there is software out there that actually will do these kinds of things, and they're written by companies to help network administrators learn and test their networks, test their networks and learn how to properly secure them. So if, let's say, a attacker filled up our switches doing this MAC flood attack and filled up the MAC address tables, also known as a CAM table, content address memory table, they could generate tens of thousands of MAC addresses per minute. Okay, and the number of MAC address entries that a switch can store, we're usually talking in the lower thousands, 4,000 to 8,000 perhaps, depending on the switch. Might be less, might be more, but it won't take long for an attacker to fill up that table. So what would actually happen is the attacker would see for a given amount of time all the frames that are being sent on that network. And if they did nothing else, then the switch would eventually, after 5 minutes, age out all those bogus entries. And now legitimate devices would be able to populate the table, and flooding would cease, And guess what? The intruder may never be detected. People may not even realize that any kind of issue even occurred. Okay, so configuring port security allows us, one of the things it allows us to do is determine how many MAC addresses are allowed per port. The default, by the way, is 1. Okay? And I'm gonna talk about these things about what happens if a violation occurs, how you can modify the number of MAC addresses per port, etc. Okay, so we'll get there. Configuring port security uses the Switchport port security command in interface mode. It's used to set the number of MAC addresses that a port is allowed to have. The default is 1. Defines what happens if a violation occurs, if it happens to get more than 1 or the wrong MAC address. And speaking about the wrong MAC address, will it be the first one that's learned, or will we want to specify what that MAC address is? We'll talk about the different methods for that. And how long does that MAC address, is it valid to enter the switch? So we'll talk all about this in just a moment, and we'll see to verify this, we use the show port security command. Okay, so the switch supports 3 types of secure MAC addresses. Static. So this is where we actually specify the MAC address that's allowed on the port. Another one is dynamic, means the first one it learns. If that's the default, is 1 MAC address is learned. If we modify the maximum, then whatever number of legitimate, if we say 3 MAC addresses are allowed, then the first 3 that are learned will be forwarded by that port. Okay. Sticky just means that, well, it will learn them dynamically, but it will save it to the running config. The dynamic option, it's not saved to the running config. So if the switch reboots, then they're learned dynamically all over again. Sticky says, oh, I've learned these, it's in the running config, and as long as my running config is saved to my startup config, next time I reboot, these are the MAC addresses that are allowed to enter the port. Again, we're talking about source MAC addresses that are learned, okay? Not the ones that are forward, just the source MAC addresses. So that's basically saying how many devices are allowed to be on that port. Okay. Now I mentioned that the sticky mode saves them to the running config. Okay, so you'd have to copy the running config to the startup config, and next time the switch reboots, it says, oh, I remember those MAC addresses, and those are the only ones allowed on the switch. There is an archive command you might be interested in looking at, which actually copies your running config to startup config automatically for you. For example, when there's a change in the running config. Okay. All right, so what happens when a violation occurs? Well, we have 3 options. The protect option says if there's a frame with a source MAC address that is not recognized or not allowed, for whatever reasons, we just drop the frame. The restrict option says if that Ethernet frame with that source MAC address is not allowed, I drop the frame, but I also send a message to the iOS. Shutdown, which is the default, says I drop the frame, I send a message, and I put the port in error disabled mode, means shutdown. So I would actually have to do a no shutdown, meaning an administrator would have to come and do a no shutdown on the port. Go say, see what happened. Say, oh, wait a minute. There's, somebody might call in, hey, I can't connect to the network. The network administrator will log in and say, oh yeah, it's in error disabled state. Looks like there's been some kind of port security violation, and investigate that before turning the port back on with the no shutdown. Okay, so how does this work? So basically, We go into interface mode, do the switchport mode access command. That just makes sure that switchport is an access port, meaning it's not connected to another switch and doing trunking. Okay, switchport port security. So that's all we need to do. So by default, only one MAC address is allowed, whichever one is learned first, and that's the only MAC address that will ever be allowed to enter the switch. Again, it's looking at the source MAC address. So a frame comes in, and the first frame it sees examines the source MAC address. It says, okay, I'm going to add this to my MAC address table, and this is the only MAC address, source MAC address, I'm going to allow to come into this port. Okay, and it stays like that forever. Well, maybe not forever, until the switch reboots. Then it starts all over again. Okay, static secure is, well, what if we actually want to specify what that MAC address is? Then we use the switchport port security MAC address and give the MAC address. MAC address is stored in the MAC address table, and it is shown in the running config. And again, we can use that. We copy the running config to the startup config, or we use that archive command to have it do it for us. Here's an example of, we want any of these 3 devices to be allowed to use this port. Okay, we've actually set the switchport port security maximum to 3. And these are the 3 MAC addresses we're going to allow. If I didn't specify these 3 MAC addresses, then it would be whatever 3 first came in that the port learned on. The first 3 devices, the first 3 MAC addresses that were learned on that port. Okay, so those 3 would be allowed. But if any other device tried to connect to this port, okay, it would be a port security violation. Okay, the frame will be dropped. Sticky secure. Okay, what that does is it just learns them dynamically. Okay, but they're added to the running config. And again, we have to copy the running config to the startup config, or have the archive command do that for us. Okay, but then if the switch reboots, it will remember that MAC address or MAC addresses that were learned. In this case, single MAC address, because the default is 1. All right, so just kind of a quick look at some of the commands here. Switchport mode access, we have to use that because the switch port has to be an access port, not a trunk port. Switchport port security is the command that actually enables port security on the interface. Then we can give other options after that, like maximum 2. Okay, this sets the number of secure MAC addresses allowed on that port. The range is anywhere from 1 to, and it just depends on the model switch. Okay, but the default is 1. Switchport port security aging time. By default, there is no aging time, meaning whatever number of MAC addresses source MAC addresses are allowed on that port, coming in on that port, that's forever until the switch reboots. Okay, or if you use sticky mode, then it remembers which MAC addresses those are. Now, this aging time, what that does, it says, well, I can actually age it out after so many minutes. This is an option. So let's say we said 5 minutes. Somebody plugged in. It allows 1 MAC address to be learned. Oh, I've learned it for 5. It's been there for 5 minutes. And let's say you unplug, and somebody else comes in. After that initial 5 minutes, it would allow somebody else to plug into that port, but only 1 MAC address by default. Okay, we can actually specify the MAC address itself. Sticky, again, just means that it is saved to the running config. And the switchport port security violation command lets us configure what we want to happen if there is a violation. Okay, so here we've set it to 4, and we've actually qualified one of the MAC addresses, and we're saying The other three will be learned dynamically and be using sticky. Show port security interface. So just what happens if there's a violation. If there's a violation, it will be put in shutdown, and the administrator will actually have to come over, do a no shutdown, but at first figure out, wow, why is there a violation? What occurred? And it shows us the maximum number of MAC addresses that are allowed on the port. Okay, using those same commands. Oh, here I'm actually showing that on this switch here, we did a Switchport port security maximum question mark, and it will tell us the number of maximum addresses allowed on that port. We did 4, just like we did before. Show port security address. It will actually show us, in this case, our one static address. This is our static address we put here. Okay. And if it's learned any others, then it will show that as well. Okay. All right, what if we set it to restrict instead of the default shutdown when we do show port security interface fast Ethernet 1 in this case? Notice our violation mode has changed to restrict. Okay, and that's a brief introduction to Switchport security.